everybody. Welcome to Analytics Everywhere. Today we're joined by Alex, the founder and CEO of Redpanda. We're very excited to have you here. Thank you for joining us. As always, I am Evan Rusakis. I'm a Superset committer and PMC member, and I work with Preset, running a lot of community stuff here. And I'll hand it over to Max for intro.
Yeah, Max, I'm also a Superset contributor. I started a project a long time ago. Also started Apache Airflow a little bit before then, and just been working on open source. I'm also CEO at Preset. For today, I'm really interested to talk about streaming in general, Redpanda, how it differentiates. I think we're going to be talking about the tech and where our technology is going to interface to. I think that's kind of a new area of like querying visuals, doing visualization in real-time data. So I'm really interested to talk about that today. Alex, you want to introduce yourself?
Yeah. Hey, everyone. My name is Alex. I am the founder and CEO of Redpanda. I wrote the original storage engine. I'm excited to be here. Obviously, I think I haven't coded in a few years now, so it is much more sophisticated and with a lot less bugs than when I handed it over onto the team. So I'm excited to be on.
I think guys, the quick thought on that is like the creators of the open source project like probably share things in common. I have the same feeling about Airflow and Superset, where some of the early versions were extremely moving fast. You need to be a little delusional to go and create something as ambitious as Redpanda, and you need to accept you're probably gonna generate more bugs than features for a little while, and then you really need for the people to kind of come and join and scale the thing and stabilize it, make it like really solid, battle tested. For that, you really need an entire community of people, all sorts of contributors. But yeah, that's kind of my story. I feel the same way about the projects I started too. It's going much better since it's not just me.
Well, maybe there's a good question to start off with, Alex. Like, what was the kind of thing that woke you up in the middle of the night and said, "Hey, I've got to start a product or a company or both"? Which came first?
I didn't actually wanted to build a company, to be honest. I wrote it. So I was in 2016. I guess a little before I've been using streaming for a really long time, like 15 years. And so for a while I went to build an ad tech and I tried all the, queues at the time, Kestrel and Kafka. And then we paired up with Apache Storm at the time and we built an ad tech that made a ton of money. And I left there to build a stream processor that I sold to Akamai in 2016. So it was a good run of that, and that went to power some important use cases. But I was sitting in my Miami apartment, and I've been writing C++ for a really long time. So I just opened up Emacs, which I guess people these days just use VS Code with some AI assistant, and on a Lenovo P50 laptop and GCC, and I just started writing the thing I wish existed for me. I didn't expect this to take off, and then it turns out that there were a lot of people that sort of jive with the ideas that I was trying. And then at some point you kind of find yourself with users, and it sort of snowballed, and I decided to become the CEO. But anyways, I really wrote it for me, and it sort of jived with a bunch of people that were in similar space, where just like, this other thing is hard to use, whatever, it's maybe not fast enough, you can lose data under some conditions, this and that. And I was like, as an engineer, you don't ask for permission, you just sort of go ahead.
And what year was that? So what was wrong with Kafka at the time? Is it just the JVM? You're like, okay, I'm not a big fan of the JVM. Or it's clunky. I know Kafka's got, it's pretty heavyweight too. So maybe that was a usability or scaling kind of, or,
Yeah, so I had a team that was, I think over 20 people just trying to stabilize a few 100 node clusters across sort of a large deployment. And it was just really difficult to understand, to be honest. And so when I started this in 2017, was working, actually I wrote my own RPC using flood buffers, and I was really into kernel bypass technology like DPDK. And I was like, hey, you could use this thing to build something that is next gen. The thinking is that the bottlenecking compute a decade ago is different than the bottlenecking compute today. And like, what would you do differently? And so I actually focused on tail latency predictability. I was like, if I can understand the system, then it'll be easier to debug and maintain. And so that's where it really started with simplicity. It didn't start with performance, but I had been working on relatively low latency systems for a while. And actually, the speed that people know Redpanda for is a byproduct of focusing on predictable tail latency performance. It's like, one of the challenges with some systems is like you get this huge spikes in variability, and then you don't know what's going to be the user experience. And so by focusing on tail latency performance, it turns out we made all of the lower percentiles super fast. And so we kind of started building on that, but it was at its core, it was about trying to make something simple that at least I could understand.
With latency, I guess that's a lagging indicator that's on the sum of all the other indicators. So for that to be fast, everything else got to be fast, I guess.
It's like, I think latency is the sum of all your bad decisions, as I like to say.
But you can't optimize for everything too, right? So maybe like Kafka was optimized for scale coming from LinkedIn, so you could scale to hundreds of nodes, and but you can't optimize for all the things at once. So what would you say you're optimizing for? So for latency as the main thing.
Yeah, originally, well, the project is now 5 years old. With I think we're a few hundred people in the company, so it's evolved and continues to evolve. But originally, I guess I would say that we wouldn't be here without Kafka. And so actually, Kafka is great, and Kafka is many things beyond what people tend to think of it as the Apache project. Actually, the community is the thing that is the largest, and is not code that lives in the Apache project, in the GitHub Apache project, is actually the other order of magnitude larger code bases, which are integrated into the Kafka API, like all of the databases.
Connectors, yeah.
Yeah, exactly. Connectivity and so on, like that applications, that's an order of magnitude, if not 2 orders of magnitude larger than in lines of code alone, but like in applications, many fold. And so we wouldn't be here. And so it was really about optimizing some of the design decisions. And so one was using a strong consistency protocol. So we use Raft. That was really important to give people safety by default. So it's like
Kafka's still on Zookeeper. Do you know that? Or
well, they have a new quorum system, but it for production deployment they still recommend having a separate quorum system and a separate set of storage nodes. And so but like while we eliminated that categorical complexity, there were other categorical complexity, like ancillary systems like an HTTP conversion so you could do curl, and schema registry, right? These services that are foundationally how you think about perhaps shaping your data as a contract for other downstream consumers, but you need these other tools. And so it was really about eliminating this categorical complexity for a while. And so I would say, if you ask me, originally we did optimize for latency and safety. So the 3 pillars when I launched it in 2019 was simplicity, performance, and data safety. And over time, we sort of evolved the storage engine into like cost effectiveness. Mostly it's been like a driver into continuing to lower the cost performance.
Do you think since you've started that, you've mentioned the kind of the optimizations have changed, the company's grown. Do you think the use cases have changed much between when you started and the current era of?
I think the use cases have widened. If I take a step back, and something that we're thinking about, or at least I spent a bunch of my time thinking about, is the notion that basically no one cares whether your app is streaming or batch as long as it feels to the user, like it does what the user intends it to do. And so if we shift a little bit higher level and think that if you have a data intensive business, basically anything that's moving a ton of data, I see platforms like Redpanda or others being a good, what I call ring zero, like base platform to then build a bunch of services. And it really, the 2 principles of the log from a database perspective, immutability and like really cost effective way of storing the events, it's just very freeing. And so if I'm building a data intensive application, then I would use something like a Redpanda. And so when you ask that question, have the use cases expanded? I think so, in 2 meaningful ways. You see migrations away from the batch companies like Snowflake or Databricks and so on, but you also see like the developers understand Kafka or streaming systems with much more nuance, which expands the natural use cases. And so we see tailwinds from AI as well. But largely, I would say, is sort of this push for convergence and push towards simplicity and push towards like actually understanding what the hell is going on in the backend. Like, how does my app work? at all. Like, you know, and so when you keep pushing systems for simplicity, you'll end up, you know, naturally expanding the use cases for which they were originally designed.
Yeah, for a while, like the folks at Confluent were really pushing this idea of like everything is a stream, data is only in motion, state does not exist,
Yeah.
it's just something we get as we reconstruct streams, maybe. I'm not sure what happened to this ideology, or if you subscribe to some of it or all of it too. There's also like everything like batch is dead, or that batch is going to die. Uh, Databases are going to be less important than stream. That kind of thought. Like, what do you think on around all of this?
Yeah, this is such a rich topic. There were like 6 questions behind it. So let's break this down. Yeah, yeah. So okay, so I agree with the core principles, and like at a systems design, we see entire companies betting their future on the idea of the log. And so Amazon even wrote, you know, when they wrote the paper on Amazon Aurora, they're like, the log is the source of truth. Everything else is a cache. And I think at a high level that does tend to be true. But the cache and the indexing layers equally as important to actually do something useful for a user. And so what we are seeing in our bed is like, hey, as the data streams are coming in, you know, we think we're great at what we do, but we're not a database company. As in, like, to provide a SQL interface that is competitive with Snowflake or someone like that whose core competency is to build the best database in the world. We're, you know, I think it would take a tremendous amount of effort and philosophy and alignment and things that were just too small to you know, even at a few hundred people to even tackle. But um so the way that I see the world integrating is like, why don't you just expose the data in a way that's queryable by your favorite database engine, whether it's Pinot or Trino or DuckDB or ClickHouse or Snowflake or Databricks or Soup de Jour. And so that is with the integration of Apache Iceberg. And I do think that the industry has settled on that as like a, I don't know, for lack of a better word, like a big data integration data format where all these systems are just converging towards integrating into one of these open storage formats that allow multiple databases to query the data. And so anyways, many questions here, but that's where we see then people querying it with a more dynamic language like SQL. But it's with regards to unification of batch and real time. Anyways, let me pause there for a second because I don't want to kind of go into a technical rat hole of, you know, timer callbacks and like SQL streaming and trying to prove this on air. That's at a high level. That's how I see it.
I think yeah, that's interesting too. I mean, the digging into like the batch versus stream too. So I remember kind of confronting some the people that were like, oh no, batch is dead. Everything's gonna be a stream, or at least like we're gonna start writing jobs that support both batch and streaming, right? And we can change whether we want it to execute as a batch. Maybe we want to save some money, or we want more immutable outputs, or maybe at sometimes we need streaming to be on for certain data sets, so we can kind of change and go between one and the other. The reality, I think, is still like we have a shit ton of ETL and tools like dbt and Airflow that are primarily batch. And if you take like just like 10% of the jobs, not even like the most complex job, like just median complexity, I think those are really might be really hard to express in streaming type pipelines too. So I don't think we've seen that migration yet, and I think it does pertain to like, it's easier to reason about, batches of like, hey, I've got this block, I do this transformation, I get this immutable block, kind of this functional programming idea of like, like really immutability, and just like these concepts being applied in the data world make a lot of sense to a lot of people. But yeah, it's like, I don't know if we see more of a migration, or if you see people kind of shifting their
What I
work.
see, it's I guess there's a cultural shift more than a technical shift towards using. I don't think batch in its form today it's perhaps going to go away in the way that we have, or at least the industry has classically sold it. What I see, so okay, so there's business reasons why you want to adopt more sort of interactive style queries like streaming. And it has to do with your ability to make more money with less, right? And so the classic example is fraud detection, and there are many, I think. But the idea is that if I transact, I don't expect any Nigerian prince transactions with my credit card at this point, right? Like you sort of expect your bank to like block it at time of transaction. That doesn't even register anymore. Like you never even see that as like a credit and a debit. It's just a thing that's sort of handled behind the scenes. Um, and so there is also the ability to make more money from a business perspective with groups of events, right? And so at a technical level, the whole reason why people thought about it is because there was a math proof that says all you need is a timer callback on your streaming, which can be itself represented by stream, to then say like, hey, call back this function at the top of the hour. And then all of a sudden you have a superset. But that wasn't enough. Where I see the industry heading towards is this, mostly because of these batch systems being there for hydrating historical context, and then you kind of running this in-memory state of your business. And so I do think that at least, but I'm biased, obviously, because I'm selling this to people that already think that way. And so my experiences are not just like with how I saw the world, but also the people that are buying software from us are like people that are philosophically assigned. And so I'm only exposed to a small subset of the world. But the way they see it is like they want this in-state business application where they're using the historical data as a way to hydrate, and then your real time as a way to continuously answer queries.
It's true that from where you're sitting, all the use cases that you serve are probably timely, where data freshness and latency is really, really important. Like, fraud detection, it's really clear that we got to do that in a very timely fashion. If you're trying to understand if, like, I don't know, this video game is selling better than this other one, or whether, user are churning faster this week than last week, like you don't really need to know whether they churn, in the last minute or so, right? So if you're doing this kind of 90 days analytics, I think the premise was like, well, if you do all the computation in a stream compatible type of compute engine, then you have best of both worlds, and you're able to do both, and then it's in theory maybe as simple, right? It's the same computation, it's just expressed in a different way. So if it is as simple and potentially can add value when freshness is important, then there's no reason why we shouldn't do that all the time. But the reality is, like, people know SQL, people have been writing store procedures and like long queries, and somehow DBT, Airflow, like SQL, batches, DAGs just work for people too, right? People are really...
It's the representation, this like duality of thinking of streams as an append-only SQL table that I think had given architects perhaps the tools to think through the world from like a SQL first perspective. Like if you take a step back and you say, I want to schematize the topic, and then that's going to look like a table. And the only operation is I can insert at the end of a table. So it's a person table, and I want to insert first name and last name at the end of the table. Then you can sort of start to mix the duality of a table and a streams. And people have written many papers about this. I'm kind of doing it this justice here. But where I think the world is not wrong, like fundamentally, is that it's about representing the data in multiple ways. And so let me explain. The fastest way to retrieve streaming data is in row orientation, because when you issue your F data, your F read from a syscall perspective, right? Like the kernel is gonna read the next 4 or 5 pages from the kernel. This, right? Like you can pipe and saturate the TCP connection at that level. But when you're doing analytical queries on it, when you're doing like, I don't know, let's say you bring a Snowflake type database, the magic is about skipping data, is about actually not reading the data. And so that comes from the indexing layer, right? Like you can query a petabyte, and obviously it's not going to read a petabyte. It's going to skip through most of it, and it's going to read like 1% of the data to actually give you the results that you want. And so the reason why I think at least the folks that I talk to tend to want to onboard the complexity of a streaming system, perhaps, is because if you have the technical aptitude from an architectural level, where the same data that is in the stream can also be queried by the best query engine, then you start to see why people think of it in that way, even if they're accessing historical data through like a Snowflake or let's say a DuckDB or something like that. Does that make sense? That's kind of how we're seeing the worlds converge, which is if you need real time, if you need low latency, I think the Kafka API is a pretty good API for that. But if you need aggregate over historical data, then frankly, it's not a good way to access because you need to skip a bunch of data. Otherwise, the performance would be terrible or compute would be cost prohibitive.
Yeah, maybe like part of the reason why batch is so popular, databases are have been more popular or used, or people seem to use them more to solve their problem. And that's not necessarily true, but yeah. So I think the human mind thinks more in terms of like maybe a state, like what is the state of things, like where are you at, instead of like where have you been, So like I think people are just like, what is the gender of this person, in my user table right now, more than like how many times did it change over the past 3 years. So I think like people really think about state too, and we to build application that's more about state than about changes, right? Like there's more information in the database right now than in the transaction log. Though the transaction log could allow you to reproduce any state of the database in time. It's more powerful than the state of the database. It has everything and more, but it's like, what do I care about right now?
Well, and I guess it talks about perhaps it like systems and architectures are now at a point of complexity. My intuition is that most businesses are some control plane level databases, and if you think of Salesforce as a control plane database, with like you do a get put delete on contacts, right? Like you can start to.
It's just a CRUD application on like whatever entity relationship you define in there.
Yeah. I actually do think that most businesses are like a control plane database that is exposed with actually relatively similar semantics. But what I would consider streaming a really great fit is for like what I define as ring zero, right? Like you have your service, some does whatever TLS handshake, authentication, authorization is like, okay, you're now like I can write this log to the stream, and then you have multiple ways of representing that. And so for ring zero, I would it gives you a lot of architectural freedoms in that if you have cost effectiveness, well, maybe today the best way to represent that index it would be Elasticsearch, and maybe tomorrow would be Postgres, and maybe the day after would be foo bar. But the ability of storing historical data at a price performance in like S3 that is super cost effective. And then you can materialize your view later down the road. I think that flexibility is still desirable.
Yeah, where streams really shine is like if you really care about freshness, like the fraud detection use case, if you care about something that happened recently, or if you care about state changes, not state, right? Like, so if you care about like, hey, when this happened, we need to fire up a bunch of things. So we use a lot of these streams at a streaming engine at Airbnb to do like cross service communication too. Like when someone books something, that's got to tell the fraud detection system to do a thing and this other system to do this. The identity validation service to do this and that. So coordination, right? Like where there's a lot of like coordination around state changes, and then these streams really become like the nervous system of this the application or the system really.
But I do want to like I think add that it like interact. So end users like you and I demand like interactivity that at a CPU level, like when it comes to systems running, it looks like a streaming system, right? Like a Twitter or a share chat or like oil and gas monitoring or car to car communication, or there's like I could go on like space exploration with. I'm just using use cases of Redpanda or like largest sporting events or metrics, right? Like when you start to think about it, is the end like at the end of the day, everything is sort of a made up abstraction, and like what matters is like, is the end user happy because of whatever software we're building? And so interactivity at the end user software will start to transitively look a lot like a real-time log, where you sort of get to base indexes on.
Yeah, it is. Whether you think the log is the byproduct, the state changes in the database, or the state changes is the thing that drives this, the log or the action is what drives the state. And it's like these two things are entangled in ways that cannot be decoupled. That's just how it. Right? So it's just sometimes I think that for some application, like one is more important than the other, right? Like it's more. I wanted to get into a topic that I think is interesting, which is I would call it like the chasm between operational analytics and observability, and this whole like analytic, think your Datadog and your tracing system, and like what, what's the CPU of this pod at this point in time. These like very kind of timely things, up to really operational analytics and business analytics, where it's really like 90 days, is this cohort of user more engaged over time than it was before? The whole, is this product selling better than this other product in this other geo? So what we've seen over the years is like a deep kind of chasm between these two spaces, with different databases, often like different stream. We could talk about whether streaming is the same across these two things. I think it might be more unified there. Different personas, different tooling, even the visualization tools. So we're more on the business. Apache Superset is much more on the business analytics side of the house, and something like Grafana is much more on the real-time stuff. The databases, a lot of time series databases where like the time index is kind of enforced, and very, very kind of well are enforced and managed. A lot of constraints around time in some of these databases. And then different personas too, right? Like the people who care about this stuff is generally a very different group of people too. And for a while I thought that, databases like Apache Druid and Pinot, and we kind of bring it all together in a database that's like low latency, but also like really fast, like in memory, very interactive and low latency. I also thought like, Apache Superset, I mean, we do support a lot of operational use cases too. There's still a chasm. Like you have some business analytics and your Grafana that's a little bit foreign. It shouldn't be there, or it feels out of context. And Apache Superset, you'll see some operational metrics too. So curious how you see that evolve, and maybe whether Redpanda is more on one side of the house versus the other,
Yeah, we started in 2019 very much on the operational side. I mean, we have I posted a tweet. Someone sent me a screenshot where they pushed the product, frankly, even beyond what I thought was possible. It's like 500 microseconds for tail latency. That's so unbelievably fast that it blew my mind. Just like, hey, this is in production. They're like, customers super happy, and they send us like a little graph of the tail latency. So that's probably the strongest view. We're going to be releasing this idea, and like what people tend to struggle with is this, like, for lack of a better word, there's like dumb pipes that you just need to be super cost effective, effectively an S3 overlay, where you can send your data and it's fine. It takes a few seconds. What we see is that the responses from these object stores on these dumb pipes are in the multiple seconds. Like, it's not uncommon to see latencies in the 2, 3, 4, 5, 6, 7 seconds regularly. And so the gap, right, it's so vast. It's like taking a jet versus going to space in terms of latency. And so that's why from at a user level, they feel like two personas. But like, okay, the person that needs a jet engine is not the same person that needs, that can wait to go to the moon and back, because it happens every 50 years, I suppose. And so however, what I do think that engineers, or at least companies like Redpanda, we've been offered by the cloud vendors, is this uniform API for this high throughput object storage systems like S3 or GCS or Azure Blob Store. And so what we're going to be talking and releasing about is that the developer should be able to shift away from thinking wholesale into thinking in terms of topics or tables, right? Like much, much smaller granular level of thinking, because you can have use cases, like even if you go and log into one particular website, so let's say like a Twitter or Facebook or LinkedIn, it doesn't matter. There are parts of those widgets that need to be real time, like your messaging, because you're interacting with people. And there are some that they don't need to be that fast, and it could wait for multiple seconds. And so having to deploy multiple systems is sort of a nightmare for the ops. And with this like unified API, which is effectively the S3 API, you could offer a user the ability to choose, basically as a function of dollars spent, do you want super cost-effective way that is just a write through this high throughput object systems, or do you want low latency? But there's the mental shift, at least the way I see the future for streaming systems, is that you opt in per topic or per table or per a small fraction of the use case, right? Than like wholesale.
Can you change it on the fly too? So for a topic or another to be like, oh, we're just launching this new product, so we need very timely data. We're going to monitor the launch, as we launch it. Maybe like after the launch is successful, we're going to turn it back to cost effective and kind of change that as you look at it.
You
Or
can go from really fast to really slow, right? So you can go from like, more dollars to spend to like fewer dollars to spend. The alternative it's really hard to do. We haven't committed timeline to that, but we've committed because you're right. It's exactly like you said. Is the default reaction is like, I want to pay a ton of attention once I figure out like what's the dollar, what's the revenue, what's the margin that this product is going to drive. Then I can sort of decide where to do it. So pushing it over into a write through cache to object storage systems is easy. But the alternative, we have to spend more time figuring out. Technically, my engineering team tells me it's possible, but haven't committed a roadmap on that. And like
possible, it's just trade-offs in the end.
yeah,
Everything could be possible. It's just a matter of like, how much of an estimate that you can put together. Interesting, but yeah. So like going back to the chasm between the two worlds, I guess it's like the operational analytics. So I get the streaming use case of like you're in the Uber app and you want to see where your driver is, and then you don't want the driver to be jumping around or be like five seconds behind. It can be quite confusing if they're 10 seconds behind where they really are. I think we've all
totally.
experienced that. So there's like
Yeah.
providing. So it's almost a stream that provides the absolute latest state. So that's really latency about, where your driver is at. Now, when I'm thinking about analytics, I'm thinking more about, bookings on Airbnb or something like that, where you like, how many bookings did we have today? But at times you're like, oh, how many bookings? We just launched a thing maybe, or we just pushed this fix. We want to make sure that, how many bookings happened in the past minute for whatever reason. And then at this point, in a place like Airbnb, we'd have to shift tools because it'd be very different tools if we wanted to look at something that happened in the past minute versus something that happened, in the
Yeah,
past.
and the way I see it there was that what I alluded to, the unification of, I suppose it is represented the data in a format that is accessible by multiple systems where like, you're right. Like I don't need the quarterly revenue every second because it's like last quarter revenue is last quarter's revenue. Do you know what I mean? Like I'm going to run my finance is going to run that query once, and that's the number, right? Like it, but like on the operational side, you may want more, you may want like faster responses for lots of reasons. Maybe it helps you save money or make more money or whatever it is. And the unifying storyline here is you want the same data, right? Like it's still the same transactions, like it's still the same credit card transactions on Airbnb. It's just being able to access your data in different ways. And I think that the unifying story is that of these open formats like Apache Iceberg or the Delta Stream, where you're like, just query the damn state on
Yeah, it's
disk,
the
right?
same
And
stream. Yeah, it's the same stream, right? It's all like the log events of like user actions on Airbnb lands into, maybe Trino on a daily for whatever
exactly.
reason, but it lands into some other the fraud detection system by the second. It's the same stream, really. I think that, yeah, so that means like, yeah, that chasm between the two worlds, I think it does not really exist as much on the streaming layer, right?
Yeah.
It's really the same stream and the same infrastructure. It's just where it lands. It will land into different databases depending on, Druid for like timely OLAP, query use cases, and Trino for, querying years of data.
And
Yeah.
what we're seeing is actually this database is adding support for things like Iceberg, though, because like having multiple copies of the data is also a problem, because basically it's like, well, which one is your source of truth? And then you have to do all sorts of checks, and like your architecture starts to balloon out in complexity. And so, by the way, this story is, I would say, is very much on the cutting edge. Like what I'm sharing, as in like all of us, the top vendors in the streaming, are like actively working on this, and like I expect news getting released over the next couple of weeks, kind of thing. Like this is very much,
Yeah, like question, like, is there any way for us to query the stream, right? So like just from a pure, like I'm putting my Apache superset engineer hat. We interface mostly through SQL to other tools, but we don't necessarily have to. Like we know how to do to connect to systems that don't support SQL. But let's say if I wanted to ask Redpanda, what happened in the past. Show me all the bookings in the past minute, by user or something like that. Is there any sort of API, or I would have to essentially become a consumer, maybe, right?
Yeah. So but by default, no. By default, our view is that like it takes a sort of a company build to do this well. I think that others have tried to do this, just like expose the stream, I think, as a stream processor that can represent it. And if you look at companies that are leading some of this space, perhaps like Materialize, right, with like they had to create a proof and a bunch of math to then go build a system to then go and represent this, just to be able to like expose it in a way that's queryable. It just takes an entire company build. And so our idea is just, instead of us building the query engine that gets in, interfaced with Superset, what we see in practice is an intermediary system of sorts. Either
Yeah. I wonder if we could do that on the fly, though. Like, this is kind of brainstorming here, but let's say if I was to instantiate a consumer just for a second, right? I just fire a lambda that says, "Oh, I'm gonna act as a consumer, ask for this time range, say past minute or 10 minutes ago. Maybe I want to compare this minute to this minute yesterday, so I'll ask for these two slices of time." And then I'm going to lend that into some sort of ephemeral, Parquet on S3, and then use an engine like DuckDB to query it once and then flush it all, like just a one time.
and that we have production users of that, by the way, right? So like what's cool about the log is it has two natural indexes. It has this monotonic counter that says you have message 1, message 2, message 3, and so on for. And then you have a time stamp, and you can query via multiple times, but assume there's one time stamp because time is a complicated thing. So let's just assume one time stamp.
One time dimension. So that's flaw in the streaming systems we have too, and some of the time series databases, right? Because there's the booking date, like when people ask for the booking, but when it was achieved, when it was accepted, when it was canceled too. So sometimes that's
when it was like received by the server, and there's like time drift between multiple servers, and otherwise you have to establish the transactions. And then there's like cases where they even transacted, but the entire data center goes down and comes back live. There's like late arrivals are really difficult to resolve.
Yeah, totally. But we have like a main time index that works for both of us, right? Like that's the main one for the stream, and the one I happen to care about for my use case.
Then that works to that.
Like, instantiate a consumer, run a query, apply my predicate or on a consumer, right, and then dump it in this ephemeral thing, maybe DuckDB, query it, return it to the user, and call it done.
Yeah. No, that's super common because even if you read a little more on the end, it's fine because the database will do the right thing, right? So like at its core, the notion is you fetch this even the Kafka API internally uses this notion of a batch. It is otherwise cost prohibitive. Like flushing the TCP buffer with 100 bytes is incredibly inefficient because the minimum transfer is 1400 bytes. So you have to like pad it anyway. So it's like there's like some down the wire limitations that you need some minimum. But if you skip a bunch of that and you just say at a high level, yeah, you can use the time index that is natural to the eventing system that says like, hey, read midnight. And you can read at super fast rates. Like we're talking about multi-gigabyte per second reads. We have a customer that's doing like 14.5 gigabyte per second read. So like really fast.
Predicting, so say if Superset was to look at the bookings in Australia, then the filter, so the consumer would have to read the entire thing, kind of apply its own in-memory predicate as it reads it. It would receive the stream and be like, okay, I care only about Australia. Let's flush the rest. I'm going to load that into a temporary DuckDB, maybe run an aggregation, a question on like, I know Kafka originally, I don't know where they're at, but like originally the stream, like Kafka was not super like stream or topic aware. There's no schema enforcement that they brought the schema registry later on, but it was pretty loose. So for us to be able to query something that looks or feels like a table, we need a schema enforcement. So I'm curious, like how you do schema or schema registry management,
So we built it into the service because what we found is, we have a schema registry and an HTTP proxy because exactly like you said, people want this sort of data contract style communication, which is like this is a shoe, or this is a house, or this is a person. Well, you need this like higher level concepts to actually make sense of your data. In fact, it's more strongly in a real-time setting than in batch, because in batch you can code in Python if before midnight, February, whatever, then like use the schema and then like you write like a janky glue piece of code. Yeah.
You need that for you too, right? Like you need to keep track of this schemas and time. So you need some
Yeah,
sort of,
but you do it explicitly through like the natural schema evolution.
so you have that main time index, and you'll say this schema applies for this time period for this based on this first.
So the native support is 3 schemas, like basically JSON schema, average schema, and protobuf schema. And so like the underlying type gives you the evolution rules. And so like if it's protobuf, you have to append at the end, not delete any previous indexes.
Same with Riff, yeah. So these have forward compatible or backward compatible, semantics and
yeah, exactly. And so even if your definitions are large in memory, it doesn't mean that your actually memory structure is going to be large. It's just that the IDL may be large, but that's all built in. So to answer your query, you could go back and answer that and then ask the built-in schema registry, what is the schema of this thing? That's actually how bank checking accounts work in the US. We power some of the world's largest banks. And like you just described, so when you go into a checking product, it is like almost down to a T, minus the ephemeral piece, is exactly how it works.
If we can make it look like, create like a database proxy on top of this thing, that'd be so cool. Like if you had something that looks and feel like a database, you talk to a proxy, then it talks to the schema registry to expose tables, and you can do a select star from something where time index is equal to that, or run, and then you just populate it in DuckDB, run the query ephemerally, and then flush the memory like nothing happened. That would be like it's almost like a Lambda database on stream. I don't know if that exists today. I don't know if you need any open source projects like that, but I'm like, oh, I think I got a weekend project here.
Yeah. I wish. I think as a CEO, the other day I went to a hackathon and I was like working. Anyways, I had like 2.5 hours free, which is more free time than I usually have. And like my first reaction was to git clone the DuckDB C++ repo and start hacking something that looked like that. I didn't make much progress. I did manage to compile and teach it at command, but I didn't get a chance to do much farther. I don't know if anyone doing this.
I'm curious if people are listening to are interested in this topic to reach out to, because I'm like, I can't think of any blockers where you couldn't do that. Right? And essentially, like your Redpanda cluster, if there's like a registry, you can question to be like, what are all the topics? What do they look like in terms of schema? Like how do I serialize how do I deserialize this stuff? There's no reason why you shouldn't be able to tap straight into a stream to run arbitrary real-time query. And historical, right? If you have 2 weeks on your stream, you can go and query, this week compared to last week,
Yeah.
Heavy,
and it's not that much data actually. When you look at like what can a TCP pipe give you, like you're talking about like multi-gigabyte per second workload. So like it's fine if it takes like 3 seconds and you've read 10 gigabytes that you can filter and query.
I mean, it's like a table scan in some way. Well, there's that time index, so you would get the performance related to how much you scan on the time index. Is there a way to query? There's probably no way to kind of query subset of the stream, right? It's either you get a time portion of the stream or you don't. You cannot be like, oh, just give me, or I guess you have partition stream, right? You could say, oh, if we partition on, geo, you could say where geo is equal to US or something.
And we introduce in broker WebAssembly on the write path. And so we are thinking about introducing WebAssembly on the read paths, which you can then use to push down a predicate onto the storage engine with arbitrary compute that can then execute a WebAssembly filter as you're reading the data. So you're actually never sending the TCP bytes through the wire over onto this proxy. So, but we're basically designing an entire new company. So for people listening in, there you go. This is like this is your next startup.
Yeah, I thought like the delusional me was started a bunch of open source projects. Like this is a weekend project.
Like, this is a company. Easy. Well, speaking of new things that are on the horizon, I've got to ask the obvious kind of question of the year, I suppose. What are your thoughts on, or what are the bets you're placing on AI, and how is it affecting your product, your team? Where do you stand on all this?
Is AI a fad?
Not spicy questions at all. So like I do think that like enterprises want to build these magical user experiences, like, we've seen some pretty cool demos, and in practice, we see very few people making money for their businesses with AI. And our take on it is that it wasn't the model, because you have companies like Mistral and basically Facebook Llama, excuse me, Facebook Llama 3.1, with a state-of-the-art performance. So actually, if you look at the high-end models, there is no 10x better model. Like a Llama 405 billion is very similar in performance to Anthropic and OpenAI, and now you can run it yourself and sort of de-risk the model. So you have these models and you have the data, but the long pole is actually the enterprise envelope. It's like, what is the authentication and the authorization and the schema and like the role-based access control and like all of the things that I think we have been good for a while. So we bought a company a few, like 16 weeks ago, and it was this company around connectivity. So I think we have something now like 264 connectors. Some of them, to talk about AI, is this ability to subscribe to a stream, and then and if you say like, hey, this pipeline I want it to be enriched by Llama 3.1, let's say 8 billion parameters, because you want lower latency, then it'll go to Hugging Face, download the model, load it onto a GPU, and like start enriching your streams. But it also gives you connectivity for prototyping towards these APIs like OpenAI, Anthropic, Bedrock, and Gemini. So our bet is that for the enterprises, they want to run and own and manage the data. Like they don't trust service, they don't trust the result. And so a bank in Texas that we were chatting with in New York, they're like, if I screw up a credit score because of the wrong input of training, like gender bias or racial bias or like some other like bad
once
data.
and only one stuff, like you get the same data twice and like sum it twice or something like that.
Yeah, exactly. Or like you add it, or just like they just don't trust like what was the input data that produced this output that then had like real business impact. And so the tracing and auditing, that tends to be the long pole, and they also don't want to share their data with these vendors because they feel like they're going to use it for training.
Yeah, I would say one thing about AI that I think is interesting, or we've been talking about open source or both like commercial open source companies, but like one thing that's interesting to see about AI and open source is that usually we've seen like open source being a tidal wave. So you'll see like a first wave of innovation, for instance, is business intelligence, and it's something like Superset will come to get as good or better than what existed before on the proprietary side. With AI, it's barely born that open source is like better than the non-open source thing. So it's one of these things where the tidal wave is almost ahead of the technology wave. I think we're going to see that where open source is not going to be lagging anymore, right? Like in the new tech that are really hot, open source is like a straight competitor from like day one. That's what we've seen.
Because of fine tuning, though, like the key thing was that you can take a model, and I don't need models like
raw model, like the weights. So if you look at open weights, like the weights are as good, but then they're better because you can fine tune, right? You can make it better too, which is part of the competitive advantage of open source. But even like just the raw model now, like GPT-4 and like Llama 3.5 or whatever it is, and there's just like a model announced yesterday that's like blows even Llama out the water, and it's all open base. But yeah, I think like this in the history of technology, open source was lagging and catching up. But like in the new techs that are so critical, open source is going to be ahead, And then I think open source is done catching up. Like we'll be ahead now, which is a good feeling to have. It's something I'm noticing with AI. I'm not sure if that's going to be true of like other new tech, but I think it's generally true, right? You look data catalogs, they were born open source. Like, this like these new advancements are born open source in a lot of cases.
Well, yeah, and so when you ask that question, it's like, what is your position? For us, it's about like empowering people to build it. We're still an infrastructure company, and we're not.
Yeah, picks and shovels.
Yeah.
You're picking. I mean, you are like the transport layer for their people's AI workloads, right? Like the data that they use for training, they got to bring it to a model, and the model, like the inferences that come in and decisions that come out, they need a transport layer. So
yeah, and connectivity, because what's annoying for a developer, it's like, okay, I want to play around with a bunch of models, but I don't want to write the HTTP API to this like whatever 20 things. And
Mhm.
frankly, the APIs like change in very dumb and subtle ways. It's mostly the same. It mostly feels the same, but it's actually not the same. And so the ability to just have a connector where you change the model from like foo to bar or like llama 3 to anthropic to whatever, like that flexibility is kind of sort of the second best. So it's like the unification of access is super trivial. Bring in local models, and then on the engine side is like the tracing and auditing part. Which, like, but also look, our customers tend to be large enterprises, and so in many ways, like my view, it's sort of the lens of talking to large enterprises, like, and so that's how we are placing the bets in AI.
Awesome. I have one more question I was thinking about. Like know a little bit about, Alf Kafka is different than Flink, and then I know Flink, one of the big differentiators is it has its own kind of internal state management. And I think different things can be used there, and you can checkpoint, and you can use kind of cross uh, cross partition, tables that can be, and there are some ways, or it seems like there might be some way to kind of query those state tables that are used behind the scene, whether it's traditionally, I think they use HBase or a key value store to kind of store the state, so that we could flush to the S3, the state or checkpoint at different points in time from the stream. So I'm curious if you have any similar semantics or like state management inside Redpanda, and if so, can we query it with superset maybe, right? Like, because can it be exposed? Is it purely internal to your own API, or would there be a way to query that state management?
Great question. Right now, it's internal, but so there's like multiple things here. Remember that Flink usually connects to a Kafka app, and so in that way,
Oh, that's
what is
true.
known as
I'm thinking more like compute engine than like streaming it. So yeah, you're more transport layer than compute engine from that
yeah, but with
compare.
on the compute engine, let me give you, I think, insight into where the industry is going. And so, like with Kafka Streams, which is a really popular Java-based application framework, um, there are companies now that are exposing the state inside the app as a backed by an RPC level database, whether it's like Cassandra on the back end or DynamoDB on the back end or something like that, that then can be hooked up. And then on our own thing, so we have an open source MIT licensed engine called Bentos, and the core engine exposes the state via an API, but it's really when you're trying to bring in applications. And so the connectivity company I talked about with like 264 connectors, the majority of the connectors themselves are Apache 2. The engine itself is MIT, and the engine has an HTTP endpoint that you can query. So maybe I'll take it back to Ash, who wrote Bentos, and I'm just going to be like, hey, Max.
Yeah, like talk together. Yeah, I was really, I guess, like it's not fair to compare to Flink because Kafka's got Kafka streams, and they're two different things. And then I guess like you can use Kafka and Flink, and that's really a stream computation engine. But I know, like, do you have a primary kind of stream compute engine that you recommend or work with, or your users tend to use? Is it what it plug and play, like whatever Kafka supports you?
What we are seeing is in some ways, for most, except for the most sophisticated users, caveat with that, so like 80-20, think 80%, is actually the elimination of the like this stateful aggregation compute engine, and instead, these compute frameworks are evolving towards presenting a Postgres TCP socket to end users like Superset, where actually the entire state itself is a Postgres connection that you can query the running state of your app. But like it's sort of this like the app is the database, but it's also a stream processor concept, and you're exposing it through the Postgres wire compatible protocol. So
What I was talking about earlier with DuckDB, right? So is it
yeah,
so then Postgres stores, or is there just compute engine, or there's actually stores?
yeah, right. I guess you can think of companies, let's say like Materialize, because they're friends. I
Oh,
mean, we're friends with all with really most compute engines. But if you look at Rising Wave and others too, and Arroyo, there's like 15 companies that are doing this. But if you look at Materialize, at its core is is a computational framework. It's a stream processing framework that you can connect to it through a Postgres wire protocol and issue actually arbitrary queries. But it's really sophisticated. Like it is, what the thing that you described that is kind of cool is that it's like super cost effective, ephemeral, scales to zero.
And no
It
caching.
has,
Yeah, like
yeah,
what I was envisioning is like ephemeral and memory and then flush, but you'll start thinking about caching pretty quickly, right? Like maybe if you have like large streams and large queries at somewhere, like, oh, we're gonna cache some stuff, and then you need a company. It's not a weekend project anymore.
yeah.
Cache, then you're in company territory,
Exactly, exactly. And like $100 million of funding to actually be able to pay engineers to build something.
Awesome. We've been chatting for a little while too. I don't know if we had other questions on the list or we want to wrap up.
Yeah, we probably ought to wrap up. We're heading toward the hour length, which is good for most podcast listeners, I reckon. So
We're not Joe Rogan here. We won't abuse your time for 4 to 6 hours.
Right, time to break out the cigars. Good.
Yeah, exactly.
Okay, well, cool. Yeah, Alex, thank you so much for joining us today. We've learned a lot from you. We really appreciate your time and everything you're building, and hope that our Superset listeners go and give it a try. Is there anywhere they should connect with you directly? Anything you want to point out on the website, calls to action?
Yeah, definitely join. Join the Slack. There's like a free, there's a bunch of credits that we give out for free on the serverless account. So if you just want to play around, if you want to connect anything to anything, we are launching basically the largest connectivity that the company that we bought next week. So by the time that you're listening to this, you're going to have a really large set of connectors and a base platform that you can go around and play around with it. Otherwise, feel free to reach me on Slack. I'm hanging out usually on the community Slack and on Twitter at emaxerno. Feel free to just DM me, and always excited to connect with users. Thank you for having me.
Thank you so much. Stay close.
Yeah.
Yes.